So hello everyone, and today we will be seeing one of the problem from Gigs for Gigs. It says check if subtree. The problem is simple, that we are given a two binary trees with roots root 1 and root 2, each containing at most n nodes. Determine whether tree S is a subtree of T tree. So S should be T2, or root 2 should be a subtree of root 1. So return true if S is a subtree of T, otherwise return false. And note, tree S is considered subtree of T if there exists a node in T such that the subtree rooted at the node is identical. So identical is a word to S, towards a tree. Two trees are identical if they have same structure and same node values. So 3 and 4, you can see those are identical, and that is why root 2 is subtree of root 1, and hence the return type is true. For example 2, we cannot see 26. Is it? Yeah, it is. Both are equal. Both of the trees are equal. That is why it is true. In case if it was not 60 but 61, in that case it would be false. Yeah, just saying. So how are we going to approach this one? So before starting, let me remind you all to one simple problem of string matching, because this problem closely resembles string matching. So if I have hello void, which is string S, and we have another string T, which is LLO. So what would you do in this case? How would you understand that hey, T is substring of S? You can check L with H if it is matching or not. So for each node of S, or for each character of S, check if this could be start of T, and then compare T and the string from character. I'll say character CH. Okay, and that is what you're doing. LH and L, are they matching? No. Let's move forward. LE matching? No. Let's move forward. LLO matching? Yeah, this is true, and that is what we are going to do. It is none other, none less than, here the only case is we are moving linearly, but here we have two paths. What two paths? Left path, right path. Where do we want it to consider? Again, it's up to you. Consider whatever you want. So if I can just say that return if current matches, or return if subtree of root 1 dot left matches with root 2, or is subtree of root 1 dot right matches with root 2, and then you can say that hey, that is fine, I can go beyond. So I'll just check with root 2 equals to null, return true, because hey, if root 2 is null, then there is no other tree, because I have empty string. Empty string is matching with every string. Return true if root 1 is equal to null, then return false. Now the question is how I can understand that current is equal or not. So to check current is equal or not, I'll say var current check this tree with this tree, and simple. How do I am going to check this one? I'm going to check with the help of definition. What the definition says? The definition says that two trees are identical if they have same structure and same node values. So I need to check same structure and same value. So let's go check. Boolean check of node R1, I'll say R1 node R2, and what I'm going to do here, check structure, check value. So how do I get to see the structure? So if R1 is equal to null and R2 equals to null, that means both are null. Structurally both are empty. That means those are equal. So return true. But either of them are null. So R1 is equal to null or R2 is equal to null. Either of them is null. We don't know whom, but it is not equal. So structurally they are incompatible. And check for value. So let's check for value. We will go R1 dot data is equal to R2 dot data. So if they are equal, then that is good. Else if it is not equal, I'll return false. Again, I have checked the current node. I need to check lefts and rights as well. So return check left and right. So R1 dot left with R2 dot left. Again with check R1 dot right with R2 dot right. And that is it. Let me check this one. And yeah, it passed the sample test case. Let me try to submit this one for rest of all the test cases, and yeah, it got submitted for all the test cases. So this is very similar, this is very equivalent problem to strings as well, where we just check whether this is equal, this is equal, this is equal. Wow, now nice, this is equal. Get into the depths. 4 is equal, yeah, equal. So everything is equal. So what am I waiting for? Just return true from here. Return true from here, and then we go here, and either of tree, either of within subtree. You might be wondering why it is OR here and why it is AND here, because it is structural and value checked as per the definition. And why it is OR here? Because subtree, so again the subtree can be found either within a left part or within the right part. So that is why. So yeah, this was a favorite problem for these many company, and the expected time complexity was n plus m, and time complexity was n plus m as well. Although we don't use that much space, we just relied on stack space. But yeah, again it is cool. We can take log n plus log m, and that's what we have used over here. So cool. This was from trees and data structure. If you wanted to know more about trees, algorithm, click the video on your right, and I'll see you in the next one.